Andy here again. So I wanted a new extruder. I've recently purchased a Creality 5 Plus to complement my Ultimaker 2. And I know the extruder's poor because the arms break, and a lot of people have been upgrading with the red aluminium ones. However, I didn't want to go down that route. So I went down a slightly more expensive route, and this is the extruder on the desk today. So let's have a look at it. So it comes well packaged. So you get a motor mount, the extruder, some instructions, which is uncommon. Let's have a look. So it tells you how to put the filament in, approximate E steps, so that's quite good. Tells you what you should have in the packet and tells you how to mount the gears. Now we come to this, you have to make sure you put the gear the right way round so the grub screw is on the outermost side of the shaft, and it shows you that. You then get a manual to show you again how to put it all together, and you get a bag of bits. So let's have a look at this. Is a plastic motor mount. May not be the strongest, but we'll probably do. We'll find out when we put it on the printer. So your arm won't fall off like that. I've already had this apart to check that all the parts were there. So let's open this up. So this is the arm. This gear is on a roller bearing inside. I won't take it apart, but with an eyeglass I can see the roller bearings, and it does roll smooth. The gears feel nicely cut, and when I inspected them with an eyeglass, yeah, the machining's good. And if I rub my nail on the serrated path where the filament is, yeah, that's nice and rough, and I can feel it on my fingernail. So let's have a look at this side. So again, machining is okay. It's nice and precise, the machining, and again, the path where the filament goes, yes, I can feel it grinding my fingernail. The bearing here that it runs on, yeah, that's nice and smooth. So we'll pop that fella back in. Okay, so this is similar to an E3D hot end connection. Let's see how well that fits. So let's put it in here. Now you can see that's sloppy there, but once it's connected, take this one out for the time being. Once it's connected, and I'll pinch that, that's solid, that's not moving. And while we're here, this, I really like this connector. It's got a very positive, you can probably hear that, got a very positive mechanism. And let's see how well it grips the Bowden tube. They give you a piece of Bowden tube because if you do a direct drive, obviously, well, I say obviously, you may not know, you'd have a bit of Bowden tube in between the extruder and whatever hot end you choose. Although the E3D hot end would fit in here, when I looked at the E3D website, they recommend having a 70mm section of Bowden tube between the extruder and their hot end. Now, when I was thinking about direct drive, I thought the hot end, like the, I've got this one, but this is a Bowden style. So you say the Bowden style comes with a thicker bit here. I was thinking that a direct drive would mean you put your hot end directly onto the extruder, but I learned something when I was looking at their website, and it's meant to be down here. Obviously this would have a Bowden tube there somewhere, and then that would be there. So yeah, I learned something when I was doing a bit of research for this video. So yeah, this connection here, it puts to shame the connections that come with the chirality machines. I've already changed mine. So if I push this tube in, it goes all the way through, because that's the type of it, coupling it is. But even without the um, spacer, which they do give you, I don't get any movement. And to release it, I just put it down and it pulls out nicely. Excuse me. So really impressed with that one. This one is, it looks like it's manufactured. I'm not sure whether it's screwed, and I'm not sure how this is actually fitted in, but this is the newer type of you can see, I'll put a flash on the screen what the old one looks like. So this is all plastic other than the metal parts, and the plastic feels, it feels quality. The casting is good. There's no um, there's no extra bits hanging off anywhere, and all the profiles feel nice and sharp, so that's been well made. So let's just assemble this. So that's gonna go, it's probably easier to assemble it this way. So the rotation of that, yep, that's nice and smooth. So this is the gear for the extruder, for the motor. Again, running that around your fingers, the machining feels nice. You know, you can feel it rubbing on your fingers. That's good. And after you've got your adjuster arm and some bolts to assemble the thing. So what my interest is today, really, for this video, is the path of the filament. Okay, this is a clone, but how good is the clone? So when this gear goes in there and you push your filament through, and I believe, yes, it would come through this connector and out this end. So this is going to go in here. How good is that path? So that's what we're going to have a look at. So here we go. I've got the Bowden tube in, and I'm want to see how easy it is when you're feeding the filament up through. Now this filament is slightly curvy, so I'm just going to straighten it out. This is the supplied PLA that come with the printer. Just going to hold the gear, so I'm going to push that through. You should see it appear. There it goes. Goes straight through the hole. So that path is okay. And if we were to put a Bowden tube this end, so when you put your Bowden tube in this coupler, it will stop level with this section because it's going to hit the plastic here. So I'm going to hold that in position, push that through, simulating us loading the filament. Yeah, that's fine. So how accurate is it? So it all depends how straight your filament is, I assume. So, and let's have a look, see if we can have a look like this. Okay, that is spot on. May not show exactly as the way you're looking at it, but when I look with my eye, that filament is dead center of the gearing what it's meant to run on. So that's good. I'm pleased. So what I'm interested now is how well the filament is retained within the Bowden tube. So this is where it's coming in. So we're going to put this in the coupling, and that's all the way in. I'm going to mark it and take it out. So that's pretty much restrained by the Bowden tube, all bar 5 millimeters maximum, I'd have thought. So this side, where this is the path of the filament. So filament's coming in this way and going out there. Now, it's very difficult to see, but just there and there, where the filament is coming out of the plastic, there are like triangles coming up, which is trying to reduce the distance the filament is unsupported by the Bowden tube going into the hob gear. I'm not even sure it's even clearer when this is on there. It's very difficult, even with extra lighting. There, no, you can't see it. But I'll probably do a little drawing on the screen to show you what I mean. So we know when the Bowden tube is pressed this side, the filament will leave the end of this tube. It's then unrestrained for 5 millimeters. It's going to come out, run around the gear, or be clamped in between the gears, and then it's going to go out the other side. So the other side we know is not retained by the Bowden tube, because when we put the Bowden tube in this side, as I said earlier, it's flush. That sits in there, and you can't push the Bowden tube anymore because the hole in the top of that is smaller than that. So let me get some. I've got some nice drill bits here, Dormer, if anyone knows those. They go up by 0.1 of a millimeter, and I'm interested to see what size hole that is, because we know the filament's going to run down there. So that means the filament is going to be from there to about the tip of the triangle. You've got about 20 millimeters, or nearly 21 millimeters, of filament being pushed out by the extruder, which is not restrained by the Bowden tube. So that's going to be somewhere around about 3 mil. So let's start under 3 mil. Let's start 2.7, guessing. This is a 2.7 mil drill bit. No, doesn't go. It goes in the first half, as you can see, but doesn't come out the end. And so I don't want to force it out the end because I don't want to make the hole any bigger. So let's go down 1.6. So 2.6, right, that's going all the way through. So we know the unrestrained section on the inlet is going through a hole which is approximately 2.6, maybe 2.7. And it goes through there. So let's see. Let's try 2.9. Right, 2.9 starts, but it won't go in. Try 2.8. 2.8 goes a bit further. So yeah, 2.7 is the average, and that then goes all the way down. So probably not so important for PLA and stiff filaments, but I have printed TPU on my Ultimaker 2, which is a Bowden tube, and I've got a Titan extruder on that, and that works okay. Yes, you have to print slowly, but my concern here is we've got this section from the triangular bit here to where it meets the Bowden tube, which is not restrained by the filament. I'm not sure why they've done that. Something I'm not liking too much. So what I'm thinking of doing is to drill part way down this section with a 4mm drill bit, or maybe have to be a 4.1 drill bit, to allow the Bowden tube to go down here. This is Capricorn tube. This is the standard tube, so it's going to go down here. We have to be careful if we go down this route not to drill the extra 5mm, because we don't want to make the hole in the pointy bit any bigger. So we know that's already 2.7-ish. So my plan was to make it easy for everyone to do it. I could knock a bushing up on my CNC machine, but I 3D printed one. So that my idea is that would go in there, clamp it in there, and that is restrained. I printed it and then run a 4.1mm. I think it was 4.1. Let me just see. A 4mm. I ran a 4mm drill bit down there. So my idea is to put this in, mark the drill bit there somehow with a bit of sticky tape. So when I drill down it, the drill is going to go in all bar 5 or 6, 7mm. I'm not that confident that we could drill all the way through and then shape the end of the Bowden tube, because when that is in there, the Bowden tube will be restrained by the other Bowden tube clamp at the other end of the tube, because this tube will push all the way through there, so it will be restrained by the other one that's this end, and this will also be up against the 2.7mm hole that we're leaving in the plastic, so it shouldn't go any further. So I don't think I'm going to ruin it, so I'm going to do this off camera. So I've made my insert, I'm going to put that in there, I'm going to put that in there, I'm going to bolt it up so it doesn't move. I'm going to then drill down and hopefully not ruin my new extruder. So I'm going to be back in shortly. So it all worked. Now if you do attempt this, when you do the drilling, obviously you've marked the depth of your drill, but when you start drilling, so it's going to go in, the drill's going to go in the depth of your spacer. But when you start drilling, the drill's going to pull you down into the material. So you need to be aware of that and drill slowly. So although let the weight of the drill take you into the plastic, but do what we call peck drilling. So you only want to drill a few millimeters at a time, because the drill is obviously twisting down and it wants to pull the drill down this way, and we want to stop when our mark gets to the top of the plastic. So if you're overly concerned, having just done it myself, I would recommend that put the mark where you want it, and just be aware that when you're drilling, you need to be peck drilling, so you're pushing it down, pulling it out, and you're just taking off a slither at a time. And it went well. So I used a 4mm bit. Now I've got Capricorn tube in here, and it goes in. I'm not sure whether the white one will go in. The white one's tighter, so if you were using white tube, you might have to get a 4.1mm bit. Let me just see the differences of 4.05. Yeah, see, that's why it goes in. It's under 4mm. Okay, so if you if you haven't got Capricorn tube, you're going to have to measure your bit, and you might have to go 4.1, but Capricorn I use the 4mm. So my idea now is that when we put that in there, we push our tube in. Okay. Right, because the Capricorn tube, it needs to be straightened. You can see the slight bend on that, so I'm going to straighten it up. Yeah, it's gone all the way in. So now I'm not sure if I can get it out. No, I can't get that out now because the tube is right away in. So if I withdraw it now, see, I'm all the way down there. So I'm happy with that. Obviously, I need to cut. When I install it, this Capricorn tube will be cut flush. But let's just push it back in again. That's all the way in. So let's just do one more test. Obviously, the Capricorn tube shouldn't go all the way through because it should be stopping. Yeah, pretty much where I drilled it. So I'm happy with that. That's worked out well. I don't think I've ruined it. So let's put that in there. That's there. Let's put, no, we don't need the top. So we're feeding the filament up here. Now let's put the Bowden tube in to do a proper test. So we're feeding and we want at least one gear in. So we're going to push that up there. That's going to go. Yeah, okay. I did think that now obviously that is now hitting the Bowden tube. So yeah, just twist your filament because we now got less wiggle room. Obviously our Bowden tube was back here. When we were pushing the filament from here into this space, it was unrestrained, so the filament had more wiggle room to find the center of the Bowden tube up here. But now our Bowden tube's down there, it's a little bit more difficult to get the filament in. But I'm happy with that. I want to see how loading goes. But yeah, look, that goes in there fine. It depends how. Obviously, that filament's quite curvy. If I straighten it out. Okay, that's straight. Yeah. So that's going to make loading, but that's gone easier now that I straightened it out. So yeah, I'm fine with that. So I class that as a success. So let's take this out and let's get this little thing assembled, and then we can get it on the printer. Hurrah! So I've checked the grub screws are tight in here. That goes on there. The pin goes in there. I'm going to take that back out. It's easier to put that in first. Mesh the gears. Put that little fellow in. Now, yes, I took a photo to remind myself to tell you, and I haven't told you. Now that the tube is gone in, you'll see on the photo, and I put it in, that I can just see the top of the Capricorn tube in this section here. And this is where the, have I got one up here? A stepper motor would go to. I know I've got a stepper motor here somewhere. So when this is together, and I'm just going to do it very quickly. They say that should be about 3.5 mil. that when that's assembled, the shaft length doesn't protrude onto the Capricorn tube. So I was concerned about that, and it's turned out better than expected. Obviously, if you do the white tube, you're drilling at 4.1 mil, so you'll see a slither more. But say the shaft stepper motor won't catch that because it doesn't go in far enough. So let's get it all assembled. So pin in first. And I believe that when I take off my stepper motor off my Ender 5 Plus, I'm expecting the gear on there to be a press fit. So I'm going to have to warm it up or get a Dremel on it to be able to take it off or cut it off, and it'll go in the bin. What am I doing? Yeah, that's right. Okay, now we're going to put the spring on. I would have thought the washer's going to go on like that. That's putting tension on there. Happy days. So the Bowden tube is, that's feeding. This should go in all the way down. That's all the way in. That's in just a little bit. Push that up there. Can you see anything? No, so you can't see the filament going in, but you can pull that up to separate the gears slightly. Yeah, I need to get the motor in there to see how well that loads in, but I am happy with that. And also, if it's a problem finding the end of that, we could always just, let's see, that should be 1.75, so 1.8. 1.8 goes up there. So 2 mil doesn't, which you expect. So if feeding in the filament is a problem and we're struggling to find the center of that, you can always just increase the diameter of the inner bore just to let the filament locate. But I won't know that until I get it on the printer. So I will see you in the garage.